Welcome, guys. So today we shall be looking at differentiation on subtopic differentiation of a constant in the form of ax, x raised to the power n, and ax raised to the power n. Before I forget, this is Madi Jibuma channel. Okay, so let's look at them quickly. So for us to differentiate a constant, differentiation of a constant, the result when we differentiate a constant is always zero. So let's say if we have y equals to c, y equals to c, where c is a constant and we are asked to differentiate this y equals to, let's say, 2. When we differentiate that with respect to x, the answer is always 0. When we differentiate any constant, the answer is 0. How? We know that x raised to the power 0 is 1. So if we write this one can also be written as x raised to the power 0. We know that any number raised to the power 0 is 1. So this again is the same as c. But let's just write it in that form. Now let's say we want to differentiate this one with respect to x. Okay? We differentiate y with respect to x. And if we are doing that, so take the differential dy by dx of y. Okay? So if we differentiate this y with respect to x, the basic rule is that you are going to multiply the coefficient, okay, of x by the power, and you subtract 1 from the power. Okay, so you multiply the power and the coefficient of x and you subtract 1 from the power. So that's the basic rule about the basic rule of differentiation. Okay, so let's say this is 0 multiplied by the constant, so it becomes 0 multiplied by c times x, 0 minus 1. So that's the basic rule. We multiply the power by the coefficient of x, which in this case is c, and we reduce 1 from the power. So now this becomes 0 multiplied by c, x raised to the power minus 1. But we know that any number multiplied by 0 is 0. So hence our answer becomes 0. So it means dy by dx, differentiating y with respect to x, becomes 0 for any constant. Okay, so that's the basic thing. So if you look at these problems here, I have up to 10 problems. The first 2 are in the form of differentiating a constant because you don't have any variable here, meaning x. Okay, which of course you can also write them in this form. Okay, so let's say we have so for the first one, it says y equals to 3. So if we differentiate this dy by dx, it becomes what? 0. Okay, because it's going to be 3x raised to the power 0, which in this case becomes 0 multiplied by 3 x raised to the 0 minus 1, which is 0 multiplied by 3 x raised to minus 1. But any number multiplied by 0 becomes 0. Okay, so that's it. Then the next one says y equals to 4. The same thing, your dy by dx was equals to 4 to the power 0, and this is 0 minus 1. Okay, so this becomes 0 multiplied by 4x raised to minus 1. Any number multiplied by 0 becomes 0. Okay, so the differentiation of a constant is 0. When we differentiate the next two again here from these problems are in the form of ax, where a is a constant. Okay, so we have you have to differentiate say y equals to ax. A here is a constant, so your dy by dx equals to, now here the power of this is 1. Okay, the power of any variable without an indicated power is 1. Okay, so meaning the power of this is 1. So now you are now going to multiply 1 multiplied by this constant. Okay, so it's going to be 1 multiplied by a times x, and this is now 1 minus 1. Remember, the initial power, the natural power of this variable is 1. And as I told you from the last problems we solved, that we always have to subtract 1 from the power. We take 1 from the power. Okay? We multiply first the power by the coefficient of x or any variable here. Then we subtract 1 from that power. So this now becomes dy by dx equals to 1 multiplied by a becomes a, x raised to, this becomes 0. Okay? So now, any number but x raised to the power 0 is what? 1. So therefore, your dy by dx becomes what? A multiplied by 1, which is a. So when you differentiate the form ax, your answer is always the constant. Okay? Your answer is always equals to the constant. So for example, we have y equals to 3x. A here is what? Is 3. Okay? So if you want to differentiate this one, your dy by dx becomes, this is, remember the power of this is 1. So it becomes 1 multiplied by 3. Okay? X, you take 1 minus 1. So this becomes 1 times 3 becomes 3. X raised to the power 0. But we know now that x raised to the power 0 is 1. So it becomes 3 multiplied by 1, which is 3. So when you differentiate the form of ax, your answer is always a. Okay? So the next one says y equals to 4x. So the same thing here, your dy by dx equals to, the power of this is 1. So 1 multiplied by 4, x raised to 1 minus 1. So this becomes 1 times 4 becomes 4, x raised to the power 0. Any number raised to the power 0 is 1, so it becomes 1 multiplied by 4 multiplied by 1, which becomes 4. Okay? So that's it for the next two problems. Let's look at the form of x raised to the power n. Okay, so let's look at the next problems. So now in the form of x raised to the power n. Okay? So this time around, the powers, let's say the powers of x or the variable are greater than 1. It can be again 1 as well. Okay? Now when we have this, it's more like what we've done so far. Okay? This again the same thing. So now you're going to multiply n here by the coefficient of x and subtract 1 from n, because n serves as the what? The power. Okay? So if this is y equals to that, so your dy differentiating y with respect to x, okay, is equals to, you're going to multiply now, n multiplied by this, so it becomes n multiplied by x. Okay, the coefficient here, which is 1, then we are going to take n minus 1. Okay, so that's the rule for us to differentiate this form. When we have a power of x, so we take n multiplied by the coefficient here, and we subtract 1 from n. So that's it. So this now becomes nx n minus 1 as your answer. So let's say we have the next two problems, which are y equals to x raised to the power 3. We want to differentiate y with respect to x. Dy by dx becomes, remember this is n, so it becomes n multiplied by 1, and 1 times x is just x, and we take 3 minus 1. Okay, so now this becomes 3 multiplied by this becomes 3x, and we subtract this becomes 2. Okay, so therefore your dy by dx becomes 3x squared. So that's how we differentiate this from x raised to the power n. We take n, just look at this one. Okay, we take n, multiply by the coefficient here, and subtract 1 from n. So that's it. Okay, now the next one says y equals to x raised to the power 4. The same thing, we have dy by dx, differentiating y with respect to x equals to, this again becomes 4 multiplied by 1 times x, which is x already, so 4 minus 1. So this becomes 4x, you subtract that becomes 3. So your dy by dx becomes 4x raised to the power 3. Okay, so that's it for this type of problems in this form. Okay, let's look at the last four problems, which are in the form of y equals to ax raised to the power n. Okay, so now we are assuming that we already have a constant here, okay, which most often, let's say it's greater than 1. So we're not talking of 1 here, because always in all the problems we solve, we have a constant there. Okay, for those that you didn't see any number here, it means the coefficient there was 1. Of course, I said that. So now let's say there's a number greater than 1 here. So it's the same thing. Okay, you just need to multiply the power by this constant, by this coefficient, then you take 1 from the power. Okay, so it means if we are differentiating dy by dx, this becomes n multiplied by a x raised to n minus 1, okay, which becomes na x n minus 1. So that's the form. So that will be your answer. So let's say if we have the first one here, which says y equals to 4x raised to the power 3. So this is your what? Your a, this is your x, and this is your n. So it's the same thing. Your dy by dx equals to, you multiply 3 multiplied by 4, you have x, and 3 minus 1. So this becomes 3 times, this becomes 12x squared. Okay, so that's it. So therefore your dy by dx becomes 12x squared. Okay, so the next one says y equals to 2 over x over x. Now, whenever you have in the form of course, we'll get to that point where we deal with quotient rule. Okay, but now let's say you have this form in the form of division. Most often, it becomes very difficult for you to be able to solve it this way directly. So what you have to do, you have to play with your indices. Okay, so in that, what it means is that you first have to take this one, you turn this fraction to a whole number, okay, by giving a negative to the power. You know, this can also be written as 2x raised to the power minus 1. Okay, this is the same as this, because remember this one can also be written as 2 divided by 1 multiplied by 1 over x. You multiply this, becomes 2 again, and you multiply this, becomes x. Okay, so now let's say if you have it this way, so this becomes 2, and 1 over x is the same as x raised to the power minus 1. If you want to change that to a fraction, it becomes 1 over x. If you have x raised to the power minus 2, you want to change that, it becomes 1 over x squared. Okay, fine. Of course, most of these things we've discussed them in our algebraic expression. Okay, you've completed algebra. So if you're interested in that, just check the YouTube channel. Got lots and lots of videos there. Okay, so now let's say, so you've changed this one. Now you want to differentiate. What I've done here, I've not differentiated. Okay, all I did was just to change it in a form that will enable me for me to be able to differentiate this question. Okay, this function. So now if I differentiate dy by dx, now becomes, remember I told you this is n and this is a, you multiply minus 1 multiply by 2, then you have x, and this becomes minus 1 minus 1. Minus 1 here is the initial, let's say it's a natural constant that it has, okay, from the question. And now you are taking minus 1. As I told you, you always subtract minus 1 from the power. You multiply the power with the constant or the coefficient of x or any variable, okay, and take 1 from that power. So now this becomes the dy by dx, because minus 1 times this becomes minus 2, and this becomes x raised to minus 1 becomes minus 2. And most often it is advisable for you to get it back to the original form in the form of a fraction. So now if I want to change this, remember what I told you about this. So this becomes minus 2 divided by, and this becomes x raised to the power 2. Okay, so that's the answer to this problem. Remember, if you don't understand, look at it again from the explanation. I'm quite sure you should be able to understand this one clearly. Okay, so all you have to do is to change this one first to a whole number by getting the variable, raising that to a power, to a negative power. Then all you have to do now is just to multiply the power by the coefficient of x and subtract 1 from the power. And that's it. And once you are done, you have to take it back to the form where it was in this form. So if you look at it, okay, so that's your answer. Now let's look at the other. Okay, so let's look at the last two problems. The other one just says y equals to 1 over root x. There are two stages here you have to carry out before you differentiate. And the first one is for you to change this one from a root to a power. Okay, and we know that square root is the same as the variable raised to the power half. That's the first thing you have to know. Okay, so this is the same as 1 upon x raised to the power half. That's the first thing. The second thing is for you to change this one to a whole number. So it becomes y equals to x raised to. Remember, if I don't do the one again, this becomes minus half. Okay, so now all I've been doing, everything here that I've done is just the same as this. I've just changed it into a different form that will enable me for me to be able to differentiate this one. Okay, so now the next part is now for you to differentiate. So this becomes dy by dx. Remember, you have to multiply this by the power, by the coefficient here. So this becomes minus half multiplied by, this is 1 already, so you don't need to write it, x. Then you have what? Minus half minus 1. You always subtract 1 from the power. Okay, so now this becomes minus half x. Now minus half minus 1 becomes minus 3 over 2. Let's do that. Say you divide by 1 here and find the LCM. So let's say you divide this, find the LCM in 2. 2 into 2 becomes 1. 1 multiply that becomes minus 1. Okay, minus 1 into this is 2. 2 multiplied by 1 becomes 2. So you have minus half x. So this becomes minus 3 over 2. Okay, so now the next thing, you have to take this again to this form. Now let's see. So this becomes dy by dx becomes, let's differentiate this. Let's separate these two. So this is the same as half multiplied by x raised to the power minus 3 over 2. Okay, now one thing you should know, when we have x raised to the power half, this is root x. Okay, that's root x. And anything here, okay, anything, if this number that is between this fraction, the numerator, if it is greater than 1, then it serves as what? A power. It serves as a power. Okay, so it means the power of this is 1. So if this is 3, the power of this becomes 3. And that's one thing you should know. Okay, so now the next thing here, let's change this one. So this becomes minus half multiplied by, this becomes 1 over x raised to the power 3 over 2. Okay, now the next thing you have to do is to change this one to this form. Now this becomes minus half multiplied by 1 upon, this becomes root x raised to the power 3. Okay, so it becomes root x raised to the power 3. Now if I join them together, minus 1 multiplied by this becomes minus, this becomes 1, all divided by, then 2 multiplied by this becomes 2 roots x raised to the power 3, which becomes your final answer. So just take your time and break it down step by step, and you definitely get to this point. Okay, if you don't understand, please leave your comments. Okay, I would appreciate that to hear from you. Okay, but just take your time and watch again the video. I'm sure you should be able to understand it clearly. So now let's look at the last problem. Okay, so the last one here says y equals to 1 over cube root of x raised to the power 4 of x. So when you look at the last problem, it's more like what we changed, the last part of what we changed. Okay, looks like this. So now we want to look at this. The first thing, as I told you, first you have to try to change it to a whole number and forget about these fractions or these roots and all of that. Okay, so for us to do that, the first stage, say y equals to 1 upon, we have to change this one first. So this becomes, remember, because it's a cube root here is like saying x raised to 1 upon 3. But the whole of this again multiplied by what? 4. So that's it. Remember the one we just did, okay, which is x raised to the power minus 3 over 2. This serves as the power, which is this. So now this becomes y equals to 1 upon x raised to the power 4 over 3. The next thing is for you to change it now. This becomes y equals to x raised to the power minus 4 over 3. So yeah, you change it now to a whole number. Now we have to differentiate, okay? So your dy by dx now becomes, remember, you multiply this power by the coefficient, by the constant here or the coefficient here, okay? So that becomes minus 4 over 3 multiplied by, that's just 1, and 1 times x is just x, and now we have minus 4 over 3 minus 1. You always subtract again, okay? So now this becomes minus 4 over 3, then this becomes x, and that becomes minus 7 over 3. Okay, it means if you use a calculator, minus 4 over 3 minus 1, you're going to have this. The same thing again, just divide this by 1 and find the LCM. You get that as your answer. Now the next thing you have to do here, you have to separate these two. So minus 4 over 3 multiply x raised to the power minus 7 over 3. Minus 4 over 3 multiplied by, this becomes 1 upon x raised to the power 7 over 3. Okay, so this again might become minus 4 over 3 multiplied by, now we have to take it back in that form. So this is like cube root. So this becomes 1 over cube root of x raised to the power 7. Okay, so now if I join them together, this becomes, everything here becomes minus 4 divided by, this becomes 3, and then mix up these two. Okay, this is a cube root, this is just a 3, this whole number, x raised to the power 7. So that becomes your answer. Okay, so far, if you've been with me onto this last stage, I want to take this time to say thank you very much for your time. Okay, and I hope you must have been able to at least learn something. And if that's the case, please don't forget to like, share, and give, of course, the video a thumbs up so YouTube will recommend this video to other viewers out there who may be interested in the same content. Okay, and please hit the bell notification so that when I upload a video, you'll be the first to be notified. In that case, you'll be able to learn with me very fast. Okay, so for the rest of the next weeks or so, we shall be dealing with differentiation, the whole of differentiation onto applications of differentiation. So if you want to enjoy that, please subscribe and share. Tell your colleagues to subscribe to the channel. Okay, I would appreciate that. Thank you very much. Don't forget the YouTube name. It's of course Madi Jibo Math Channel. Thank you very much. Okay.